Hey everybody, welcome to video 4. This is the first video for Unit 4. We've got 4 standards in this video. This is the first one we're going to be working with. It is determining solution sets, including real and complex solutions. We're going to be talking about something called complex solutions coming up. And we're going to be finding solutions to quadratic equations and inequalities. So we're going to start with some quadratic equations, and a method to solve them is called factoring. So you may remember some factoring from your Algebra 1 class, and maybe you used a little bit of factoring in your geometry class, but I really want you to go through each of the problems because I'm going to give you some different methods that you may or may not have seen before, and they may help you find more success than you've had in the past with factoring. So please try all of them. So let's start with what is factoring. Well, factoring is actually an inverse operation. An inverse operation to multiplication. And specifically, the type of multiplication would be maybe distribution if we're talking about using algebraic expressions. So distribution is just an extended multiplication problem. So let's give a couple examples of this so you can see what I mean by multiplication and factoring and how they could be inverses of each other. So we're going to start by multiplying a monomial. That means a single term, no plus or minus, doesn't have any addition or subtraction, a monomial. Multiply that times a binomial. So you would distribute here. So I'm recommending we distribute in a little bit of a different organized way, and I want to use this to help us when we apply factoring. So I know that this would be way easy to just use some arrows and get the answer. I'm okay with that. But I want you to try it this way. The monomial here, and I'm going to leave these two boxes inside because I have a binomial. So if I have a monomial and a binomial, I would be multiplying and I would get two boxes because this is a multiplication table. So 5x times 3x is 15x squared. 3x times 1 is 3x. It is the exact same thing if you distribute it. So your result is 5x squared plus 3x. So this is the multiplication. We're going to use that idea in reverse when we do some factoring. But what if it's not as simple as a monomial times a binomial? What if it's two binomials? So here's one binomial and here's another. Well, in this case, I'm going to multiply it again using a box. I refer to this as like a Punnett square. It is not a factor box because I'm not factoring. It's a multiplication box because I'm multiplying. So if we're going to call it by anything, let's call it by the correct name. So I'm going to call it a Punnett square or a multiplication box. It does not matter which ones you put on the top and which ones you put on the bottom, so I took the binomial over here and put it there and the binomial up here. It is important that you include the negative sign. So now I multiply 3x times x and get 3x squared. X times negative 4 is negative 4x. 3x times 2 is 6x, and 2 times negative 4 is negative 8. The nice thing about this is everything is organized and I never miss a term because every one of those squares has to be filled in. So I am going to combine like terms, and I can see that these two can be combined together. So I have 3x squared plus 2x minus 8. And that is my distribution. That's my multiplication. So keep this idea in mind of just using the multiplication idea of what's on the outside. This x times this negative 4 is what fills in this box, because we're going to use this when we factor. All right, the next thing we're going to work with is reversing some of this, which is our inverse operation called factoring. And the first type of factoring is the greatest common factor, otherwise known as GCF, the greatest common factor. So I've got a couple examples here. Pretty fancy, right? And I'm going to set it up as if this was the result that is already inside of that grid. So this is the result inside of the grid. I'll move my plus sign. So I have to think about what got pulled out. And over here was the monomial. So what monomial can come out of this that is the same? In fact, it has to be the greatest and it has to be in common. So I see that they both have y's, and in fact they both could lose two y's. So I pull out a y squared. Well, if I'm thinking in the reverse order that y squared times something got me 9y to the fifth, I know I need a 9, and I know I would need 9 cubed to make that happen. If I multiply y and I result in a y squared, I must have multiplied by 1 to make that happen. So the factored form of this is 9y cubed plus 1, and that was multiplied by y squared. So my GCF is 9y squared, but the factored form is y squared times 9y cubed plus 1. Let's try another one. So once again, I'm going to start by placing this into that grid. So I have 6x squared t plus 8xt minus 12t. And what I realize is that I'm going to have a trinomial times a monomial, because that's how big this is. So a trinomial times a monomial. And if I look within all of these, they can all be divided by 2. So I'm going to be able to pull out a 2, and they all have a t in common. So 2t is my GCF. If I were to think about going in reverse, 2t times what gave me the 6x squared t is I needed to multiply by 3x squared. 2t into 8xt would give me a 4x would be needed. And lastly, I would just need to multiply by a negative 6. So the resulting factoring is 2t times 3x squared plus 4x minus 6. We got one more and it's going to look a little crazy. All right, so in this case, I need to, again, I'm just going to draw the box right around here. And I notice that I am going to have something times a trinomial because I have 3 boxes here. But I can see that they each actually have an m plus 1 in common. So that is one of my factors that gets to be pulled out. But they can also all be divided by a 7. So I will also pull out a 7. So above here, because I didn't have room, so this was technically here. Above here is a 2 and then an m plus 1 squared. Above here would be a negative 4 because that's how I got the 28, and I still have an m plus 1. And lastly, if I take out a 7 and I take out an m plus 1, the only thing that's left to make that happen would be a negative 1. So I have to multiply by something in order to make this. So my result is a little bit crazy for this one. It's 7 times m plus 1. And I'm going to use a giant bracket because I want to include this entire top part in there, and that would be 2 times m plus 1 squared minus 4 times m plus 1 minus 1. All right, we tried 3 very different examples. I want you to make a note on any of them that you have a question, and we can talk about that when we see each other next. So let's talk about factoring again, and this time we're going to be talking about a special type of factoring. But I am going to remind us of how to use that Punnett square box. So if I have, let's say 2x plus 7 times 2x minus 7. So this is a unique situation when we multiply, and if you remember what happens when we use this grid, I'm going to put the 2x minus 7 on the top and the 2x plus 7 on the bottom, or on the side. It doesn't matter. Pause the video now and see what happens when you fill these in. So pause it and then come back and check with me. All right, this should be your result. So when we go to combine like terms, we notice that these are opposites and they cancel each other out. You also can see that in the beginning that I have 2 binomials and they're just opposites of each other, or the signs are opposite of each other. And that means that these will cancel. So my final result of this is 4x squared minus 49. Now what's nice about these is they're actually perfect squares, which is where we're headed next. So we're going to talk about the difference meaning subtraction, of 2 perfect squares. The first one is 4m squared minus 9n squared. And we're going to set this up in the reverse order of the Punnett square, where this piece goes in the first box, 4m squared, and the second piece, the negative 9n squared, goes right here. And because we're working with both of these being perfect squares, If I pull out this and I say the only way to make the 4m squared, it's not the only way, but it's the perfect square way, would be to be 2m and 2m. And then if I want to pull out how I would get this negative 9n squared, I would have a 3n and a 3n. But that's not going to get me negative, so one of those has to be negative. Well, now if you continue the multiplication, let me change colors so you can see what's happening next, that this is actually going to be negative 6mn, and this one is positive 6mn, that those would have canceled and we would have gotten this, then we've actually found the factored form of 2m minus 3n times 2m plus 3n. So start by putting these two in the boxes and see if you can factor this as the difference of two perfect squares. Let's try another one. All right, this one's a little bit more complicated because I gave you a binomial as one of your factors. So we're going to have to make a slightly larger box here to see if this will work. So in this one I have x minus 3 squared, and over here I have negative 25y squared. Well, to make the 25y, I know I would need a 5y and a 5y, and one of them would have to be negative. And to make an x minus 3 squared, I'd have an x minus 3 times an x minus 3. Well, if you multiply these to fill in this box and to fill in this box, you would simply get opposites that would cancel, which means we've actually found the factored form of this. So my factored form is x minus 3 minus 5y times x minus 3 plus 5y. And there are a lot of parentheses there. But these parentheses here around the x minus 3's don't really matter once you've written it in factored form. We got one more to try. b to the fourth minus 81c to the fourth. So I'm going to start again by building the Punnett square and filling in the first and the last box. 4b squared and negative 81c, to the fourth, I said squared. Well, in order to make a b to the fourth, using perfect squares would be b squared times b squared. And then I could use negative 9c squared times positive 9c squared. When I do that, as long as I know that this box and this box will cancel to be 0, then I've got my two perfect squares. B squared minus 9c squared times b squared plus 9c squared. The difference of two perfect squares. Okay, so we're going to work on a different type of factoring, and it's called split the middle or factor by grouping. There's a couple different names, so if you were to seek help outside of my class, which I always encourage you to do, if you need to go to the Saxon Academic Center or see another tutor, is that they might not, I don't know where that came from, that they might not actually know this by the exact same name. So factor by grouping is definitely something they would know it by, but split the middle is really the same idea. So to do this type of factoring, we're going to be factoring using GCFs just as we were previously. So the GCF between the first two, this is the grouping part, that I'm grouping the first two together. If you group the first two together here and I pull out something they have in common, which is an m, then I have p squared plus 7. So I took the m out of those two. Then I go to the second group and I have to find the GCF. Remember, GCF is the greatest common factor. Between these two, the greatest common factor is a 3. So I extract the 3 and I'm left with p squared plus 7. If you were then to consider this to be a GCF problem, and I were to split it in half, my GCF is p squared plus 7. So I can factor out now p squared plus 7 out of this one and out of this one, and I'm left with on the top here an m and a 3. So I get m plus 3. So this right here is my final factored form. P squared plus 7 times m plus 3. Let's try it with the next problem. So I'm going to start by grouping them together, and I do this when I have 4 terms, when I see these 4 terms. And I group the first two and I say, what do they have in common? And they have a 2x squared. Left over, okay, GCF would take a 2x squared out of here, leaves me with just a 2x, and a 2x squared out of here leaves me with 1. It can't leave me with nothing. It can't just disappear. Now here, what do they have in common? I would say they have a negative sign in common. They have a -1 in common. And then I'm left with, well, if I just take out a -1, I've got a 2x, and I take out a -1 and I have a 1. Please notice that what I'm left with in parentheses, if factor by grouping is going to work, those parentheses have to be the same. Now we're going to separate them using the GCF idea that we learned earlier. And I'm going to factor out the GCF, which happens to be 2x plus 1, because they both have a 2x plus 1 in them. But that leaves behind 2x squared minus 1. This is where I get to stop for this problem. You guys did a great job on that. All right, so we're going to give this grouping a try again. And this one is going to be done when I do not have, so it's really the same idea, factor by grouping or splitting the middle, but we're going to organize it a little different because I only have 3 terms. I have a 6x squared, a -5x, and a -4. So to do this one, I'm going to organize it a little bit differently, and I'm going to draw that Punnett square, and I'm going to place my first term in this box and my last term in this box. And then I'm going to multiply these together. And when I multiply them together, I get 24x squared, and that's a negative 24x squared. Now I'm going to make a list of all of the options of multiplying together to get -24x squared. So I can think of the numbers that make 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. All of these numbers make that. But I have to keep in mind that the winner of my selection has to somehow make a -5x, because I'm going to combine these two boxes together and they have to result in a -5x. That's the reverse of using this multiplication table to factor. So if I start making my list and I were to do 1x and 24x, one of those would have to be negative, and I can decide which one. But either way, I don't get a -5x. This doesn't equal -5x when I add them together. So how about 2x and 12x? Well, regardless if I made one of those negative, it still wouldn't work. How about 3x and 8x? Well, this could work if the 8 was negative. So I've actually found the solution that I want to fill in the box with. I have -8x and a positive 3x. When I fill those in, I'm now going to be looking for GCFs within this box, because that's how we used it when we multiplied, is we multiplied and distributed. So I'm going to look vertically and find some GCFs. Between the 6x squared and the 3x, my GCF is 3x. Over here vertically, my GCF between -8x and -4 is a -4. Now I'm going to go horizontally and look for them. So I'm going to go across this direction. I say, what do those have in common? And we would say they have a 2x in common. And what do these have in common? They don't have anything in common. So we write +1. So we have found that the GCF for each of these rows actually helps us form the original binomials that we need to multiply together. So this is the factored form of that. Now I understand this process took a little bit of time, and you may have had other methods taught to you in the past. If those methods have worked and you often find success with them, then stick to it. If you're constantly finding error or you don't remember how to use those old methods, then you need to stop using those methods that aren't working, stop hitting your head against the wall, and start using something that might work for you better. So I'm recommending you use this. Again, if you've got something that works and works every time, then stick to it. If you've got something that fails you, stop using it. All right, we're actually going to try a different problem. I'm not a fan of this one, not to mention it had an X and a Y in it, which was very, very bizarre. So we're going to try another problem here. So go ahead and write this one down. 8x squared plus 18x minus 5. Let's factor that. I am going to start by building this Punnett square. And I'm going to put the first term, 8x squared, in the first box and -5 in the last box. And I'm going to multiply those together, and that gives me negative 40x squared. So I have to think of the numbers that multiply to 40 that I'm hoping I can get to equal an 18x. So it might come to your mind very quickly that I could just use 20 times 2. But if it didn't, then just go through the process and think 1 times 40, 2 times 20, 4 times 10, 5 times 8. Which of those is going to get me to 18? Well, if I use a positive 20x and a negative 2x, I get 18x. Now you're going to put those two numbers in these other boxes, and it doesn't matter which one you put where, it will work no matter what. In fact, you can try the opposite of what I'm doing and see if it does work. And then now you're going to take out some GCFs. So as soon as you get those numbers in the box, we're going back to using the idea of GCFs. So across this row, my GCF is a 4x. Across the bottom row, my GCF is a negative 1. The only thing I can take away from both of those is a negative 1. Vertically, if I try to find a GCF here, I will have a 2x as my GCF. And then over in this direction, I will have a 5 as my GCF. So these are my factors. I have 4x minus 1 times 2x plus 5. So that one went a lot faster. Great job. All right, so at the end of each of the videos in this unit, I'm going to be giving you a try these page, which you took from the class the last time I saw you. And I want you to use that page to try these instead of doing questions on Schoology. So you can use Schoology, however, to ask questions of each other or of me if you get stuck on these questions, but I want you to try these questions and have them out on your desk so we can talk about them at the start of the next class. So there are 4 questions I'd like you to try, one of each of the types that we've worked with. So give each of those 4 a try and see if you can get the answers on your own. Refer back to the video or ask people on Schoology if you need help.